Okay, the broadcast is started.
Okay. I'm just getting my quiz opened up here.
Emily, were you able to get your quiz to open up?
Yeah, it finally loaded.
Oh, good.
Okay, so it looks like the first question is when you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Isn't it? Isn't it skewed left? Am I thinking about that right?
That's what I am going to assume.
Makes sense.
So you want to go with that then?
Yeah.
So left.
Yes.
Okay.
Okay, so the next question, when you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed? So it looks like everything is the same except for the number, obviously.
For this, should we be using the whole
The normal probability.
Yeah.
It says if needed, so maybe.
Isn't it? Am I thinking about that right? Because isn't it the larger the sample size, the more
Yeah.
even distributed it is?
So there is something about the size.
It's the central limit theorem.
So I was trying to look and see, there's one statement in the central limit theorem in our chapter that says you have observed in the simulations that if the sample size is large, the random variable will be approximately normally distributed. So would that mean that it is normal?
I think so, because in the book it talks about how n equals 45 is a large sample size.
Right. So normal.
Yeah. Yeah.
Okay, so the next one is just the same as the first question, except for the histogram for the parent population is normally distributed.
If the graph is normal, then that would mean that it would be normal as well, right?
Yes, yeah.
Yeah, yes. Yes. Okay, so question 6, when you're taking a sample size of n equals 100, okay, so it looks like it's the same as well, except for it's once again normally distributed.
Okay.
Same as question 2, but it's a lot bigger.
On question 6, it should be normal too. And it's actually, for like the smaller ones, I told you guys it was 45, but it's actually 30. So it says a sample size of around 30 is traditionally thought to be sufficiently large to assure that X will be approximately normally distributed. This is not a definitive number, but a rule of thumb. Yeah, I thought it was 45, but it's 30.
Okay, so the next question is, when would the distribution of means be normally distributed? And then we're supposed to select all that are correct. So kind of going back over what we just did.
Yeah.
So I checked the first two and the last one.
Get on.
Yeah.
We're officially the game.
I think
That
that's what I was thinking as well. Is that good with you, Miranda?
yeah, because you have the large sample size and the normal distributed, which will always get normal.
Right, okay. Okay, so which of the following gives the best explanation of the central limit theorem?
I think it's the first one.
That's what I was thinking.
All right.
It says you have observed in simulations that if the sample size is large, the random variable will be approximately normally distributed. In other words, the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. That's the first one, right?
Yes.
It's normal, yeah. Wait a minute. Are our questions, are you saying if the sample size is large, this shape of the distribution of sample means will be approximately normal?
Yeah. I'll read the last part again. So the
Is that what you think it is?
Well, yeah, so the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. This important result is called the central limit theorem.
Okay, I think our multiple choice may be out of order. That's the only well, maybe, I don't know. Because that is the last one on my question 8.
That's my one too.
So we may have to watch. We'll just be careful. I think we should be fine on the others though, because they're not.
So wait, so what one did you guys choose? Did you choose if the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution, or did you choose if the sample size is large, the shape of the distribution sample mean will be approximately normal?
Well, whenever I was just quickly reading through, my first thing was the normally distributed one, because we had just done some problems that were normal, but I think after actually going through and reading them all, I think if the sample size is large, I think the one that you chose should be right.
Yeah, if it's large, approximately normal is the central limit theorem.
Because from what you were reading, and if you look in that section of the book, I mean, seems like that's the right answer.
So you guys, if the sample size is large, the shape of the distribution of sample means will be approximately normal?
Yeah.
Okay, that's weird because it is out of order.
Yeah, it's kind of weird.
Yeah.
Okay, so use the following information to answer the next 4 questions. Let X be a random variable with population mean equaling 10 and the population of standard deviation equaling 6. Suppose a sample of size, that's a weird way of saying that, and equals 36 is drawn from this population. What is the mean of the distribution of sample means?
What is the name of the
Oh, sorry, what are you sorry.
So then I found this equation. So it's for the standard deviation of the sample means. Deviation over square root of the sample size.
Yeah, that's what I found too. Yeah, down in the summary. Hang on just a second, guys.
So I got 1.
You got 1?
Yeah.
Okay, I have to look up a calculator really fast because I still don't own one.
Okay.
I need to buy one.
I just use my phone.
How do you have like an app on your phone?
No, it's the calculator that my my phone comes with.
And do you have an iPhone?
No, I have a Samsung.
Oh, that makes sense.
But Apple has a calculator too that I think if you tilt it to the side, I think it has square root.
Really? Okay, that's good to know.
Yeah. If my husband was home, I would play with his because he has an Apple phone, but he's at work right now.
And I just realized how stupid it was that I thought I needed a calculator. It is 1 because the square root of 36 is 6.
Yeah. I had to type that in too, and I was like, while I was typing it in, I was like, oh wait, square root of 36 is 6. Why do you have to put that in the calculator?
Wait a minute. Yeah. Yep. Oh.
Distribution.
Did you guys figure out what number 9 was?
Mhm.
Okay, let me just double check. What did you guys get?
1.
1.
Okay.
Oh. I was just looking at number 10, and I'm confused on the differences.
That's what
I am. It looks like if you go in the book, it's like the same exact equation.
That's what I was thinking, because summary distribution of sample means is the equation, and then up on section 4, the standard deviation of the sample means. So
Yeah.
So it's 10, 1, 2, I guess? Because what is the standard deviation of the distribution of sample means?
I'm going to assume so. The only thing is if you look in the section 4, wait, let me double check. Actually, I was looking in the section 5. I don't know if that may be a little bit different, but to answer the following questions in that section, it says if the sample size n is increased, then the standard deviation of the sample mean will decrease. So it doesn't really say that anything's necessarily changing, though. It just gives us the one number for each of those values. So I'm going to assume that it will be the same, if that makes sense. If they gave us more information, then it could possibly be different. I don't know.
Yeah.
So do you guys want to try out one and see if that works? Because I don't know what else we would do different.
Yeah. One, because I don't see the difference between 9 and 10. Besides, it says this standard deviation.
Right.
Yeah, I'm pretty sure we're right on question 9, but I don't know what to do on question 10. I just read through that whole section. That's why I wasn't thinking.
Yeah, because like either 9 or 10, if one of them's wrong, at least one's right. I just don't know how to find the other one. Unless on 9 when it says what is the mean of the distribution of sample means. Nope, never mind. I was thinking maybe it's 10 because it's the population mean. I don't think that would be the. I don't know.
Okay. Just looking forward, I looked at the last couple questions, and if you look in section 6, the review of key concepts, then that's where I think I found the answers. So in bold for question 11, it looks like normal would be the right answer. Well, sorry. In bold, in section 6, that information pretty much answers 11, if I'm right.
Yeah, that makes sense.
And then if you look just right above that, it says the central limit theorem guarantees. So that's got to be, then for question 12, it asks what theorem would justify your response. So then it would have to be the central limit theorem.
Yeah, that's all the same concept as what we were talking about before, right? It just gave us a greater than less than sign.
Yeah.
Okay. Like it doesn't change it because it's talking about the distribution of the population. No.
Do you want, so you think stick with 1 for now and turn them in as is?
I guess, yeah.
Okay, I'll turn mine in right now. Okay, it looks like we missed question 3 and 9. So weird. We got question 10 right, but question 9 is wrong.
So then 3, would it be right?
It's gotta be because it can't be normal, can it?
No,
Are you talking about
because
for number 3?
the population is right, and the sample size is too low to make it normal.
I'm gonna work on question 9 for a second.
I'm gonna have fun and just try 10. If I'm wrong, I'll see.
So you guys are thinking skewed right for question 3 instead?
Yeah, because it can't be. Can it?
Yeah,
I
it's
was kind
right.
of confused. I feel like I need to revisit that because I guess I didn't understand that quite as well as I thought I did.
Okay, so the answer to number 9 is 10.
Seriously?
So it's just simply the mean?
Apparently, I just took a wild shot and it's right.
I guess I'm gonna have to figure that out again too, because so that formula lets you figure out the standard deviation of the distribution of sample means.
Yes.
Okay.
So how do you go about finding the answer though? I mean, if we were given a different question.
I wonder what happens when we just do this.
Maybe it's asking like what's the mean of the
So on, oh, go ahead.
No, you can go. I'm just trying to make sense of it.
So I just typed in how to calculate the mean of sampling distribution on Google, and it says that finding the mean of the sampling distribution is easy since it is equal to the mean of the population. Thus, the mean of the sampling distribution is equal to whatever your population mean is. The standard deviation of the sampling distribution can be computed using the following formula, which is the formula that we have. So somewhere in our book, it should say something about that.
So
Yeah.
population is key. So population, okay, that's weird. Okay. Well, guys, right skewed is right for question 3, if you're wondering. And I got 100% on my second attempt.
That was pretty simple.
Yeah, not too bad.
Yeah.
I see a theme though every week where it's like quiz 1 is super simple and then second quiz is like terrible.
Not so simple. Yeah, agreed.
Yeah.
So, Thursday, do you guys still want to meet at 7 or do you want to meet at another time? I know last time it took me and Emily a really long time, but you just never know.
Yeah.
Yeah, we kind of didn't figure out how to do it until afterwards, so I'll be more prepared this time though.
Yeah, I'm gonna attempt to do that as well.